Good morning. Hi, my name is Miao Jiang. I'm a program manager on the Azure API management team. So in this deep dive session today, I'm going to talk to you about how to build a CI/CD pipeline for API management. So before we start, just a quick show of hands. How many of you are currently using API management? Wow, that's good. So how many of you have a CI/CD pipeline for API management? Oh, great. So I guess for those of you who can go enjoy some fresh air and come back in maybe 30 minutes. Just kidding. So I have a very simple agenda for today. I'll first talk about the automation challenges with API management, and then I will walk you through a suggested approach of implementing your CI/CD pipeline. And finally, I will spend the majority of my session demoing a sample CI/CD pipeline implemented using Azure DevOps and our automation tools. So as you may know, API management today is used by tens of thousands of customers. And when we talk to our customers, one of the most common questions is, how do I build a CI/CD pipeline for API management, right? Or how do I automate the deployment of my APIs? And essentially, an effective CI/CD pipeline can ensure the agility of deploying your APIs without jeopardizing the stability of running them, right? However, when you start thinking about building a CI/CD pipeline, you will quickly run into some issues. And so here are some common challenges. So most organizations today use multiple deployment environments, right, such as prod, UAT, and production. So as an API developer, once I've finished developing and deploying the backend service for my APIs, right, how do I automate the deployment of my APIs into API management, right? That's the first challenge. And secondly, once I have tested the configurations of my APIs in the dev environment, how do I migrate all the configurations of these APIs, such as policies, named values, and things like that? How do I migrate these configurations from my dev instance into the production instance, right? How do I ensure that nothing gets lost during the process? And finally, an API management instance is often a shared asset by multiple API teams, right? And each of these teams are responsible for one or more APIs. So if multiple teams are making changes to a shared API instance, how do I make sure that the changes, the deployments from these teams do not collide with each other, right? So that's the third challenge. And unfortunately, the answer to these challenges is it depends, right? There is no one-size-fits-all solution because there are multiple factors you need to consider here, such as what's your team structure? Do you have a single API team or multiple API teams? What's your engineering culture, right? Is it a low-trust culture where there's a central team who's responsible for everything? Or is it a high-trust culture where each API team is responsible for deploying their APIs, right? And also, you need to think about your existing tools and processes. And finally, as an Azure service, API management offers a variety of deployment options, and you need to decide which one works the best for you, right? For example, the Azure portal works for some customers who have few APIs and who do not need to update these APIs frequently, right? But it's obviously not an automated approach. And to automate the deployment, some customers use the REST API or PowerShell commandlets. However, to others, PowerShell and APIs feel a little bit imperative, not declarative, right? And we also have the classic Git deployment feature, which we shipped about 4 years ago. And some customers have been using it. But it also has some limitations. For example, it does not support partial deployment. So if I need to deploy just a single API, I still need to deploy everything altogether, right? And also, it does not support RBAC, and it uses a custom JSON format, which is not consistent with the rest of Azure. So finally, there is resource manager templates, which aka ARM templates, right? And this is our recommended deployment option for a variety of reasons. First of all, it is consistent with the rest of Azure. It is it can be easily automated, right? It is declarative, and it is idempotent, right? It also supports partial deployment and RBAC. So with that being said, let's take a look at a suggested approach of implementing your CI/CD pipeline for API management using ARM templates. So let's say in this example, my organization has two deployment environments, production and development, right? The production instance is managed by a central team called API publishers. And then API developers, they only have access to the dev environment to test their APIs. So the key in this approach is to keep your API management configurations in ARM templates. And you also need to keep these templates in a source control system. So throughout my session today, I'm going to use Git as an example, but you can use any source control system that you prefer. So as you can see, for my production instance here, I have a Git repository called publisher repository, which contains the configurations of my APM instance in ARM templates. And there are different types of templates here. First of all, I have a service template, which contains the service level configurations of my APM instance, such as custom domain name, pricing SKU, number of scaling units, and so forth. And then I also have a number of shared templates for shared resources across my APM instance, such as products, groups, loggers, and so forth, right? And then for each API, I will have one or more templates which contain the configurations of these APIs, such as API definition, operations, policies, named values, association with products, and so forth. And each of these templates can be deployed individually. So if I just need to deploy a single API, I can always just deploy that API template. However, if I want to deploy everything in one shot, right, I can also use a master template which links to everything. Okay? So for API developers who work on APIs, they will fork and clone my publisher repository to create their developer repository, and they will be working on the API templates for their APIs and deploy those APIs to the dev instance to test those APIs, right? But if we think about this approach, there are two challenges here for the API developers. First of all, we know for a fact that many customers, they prefer to use our Azure portal experience to configure their APIs in API management, right? So for those developers, for those customers, how can we help them to generate ARM templates based on their configuration, right? So for that challenge, we have created a tool called Extractor. Essentially, the extractor can extract configurations of your APIs in API management into ARM templates so that you can deploy those ARM templates to a different environment. And the second challenge here is that we know API developers, they always work with Open API specification or Swagger files, right? So if I have a Swagger file for my API, how can I create an ARM template based on this Swagger file so that I can automate the deployment of this API into API management, right? So for that second challenge, we have created another tool called Creator, which essentially takes an Open API specification, and optionally, you can also provide the policies that you want to apply to this API in an XML file. So the creator will take these files and deploy them, and generate ARM templates based on these files so that you can deploy your API into your APM instance. So with these tools, it will make it a lot easier for developers to create the ARM templates. And once they have their ARM templates created and the APIs tested in the dev environment, right, API developers can submit a pull request back to the publisher repository to publish their changes to the production environment, right? And this is when the API publishers can validate the pull request to make sure that the templates are safe and compliant, right? And a lot of these validations can be automated, obviously. And after that, the pull request can be merged and the changes can be published to the production instance, okay? So this is the suggested approach. And if we think about that, there are multiple benefits here. First of all, since everything is in ARM templates, right, it is very simple to automate your deployment. And second, again, since everything is in ARM template, it's very easy for you to migrate your configurations from one environment to another, right? And third, because different API teams will be working on different API templates or different files, right? So it's less likely for them to step on each other. And finally, this approach is very flexible. You can adapt it to fit your DevOps requirements. For example, you can use, instead of using multiple repositories, you can use a single repository with multiple branches, or you can add more deployment environments here and use different kinds of tools to implement this flow. So it's very flexible. So the approach that I just talked about, as well as the automation tools I mentioned, published on GitHub. You can find it at this link, 8k.ms/APIMDevOps. And the tools are open sourced, so you can easily extend and customize the tools to fit your need. Okay, so with that being said, let's take a look and see how this approach works in reality. Okay, so let's say I am an API developer, and for my organization, I have just created a new API called the food truck API, which essentially returns a list of recommended food trucks around our office, right? And I have just deployed this API to an app service, and here is my app service. And if I click on the Browse button here, essentially I have a very simple website that calls the API and posts the list of the food truck, right? And for this API, I also have a Swagger file, which defines this API, right? So everything looks good now. As an API developer, I am ready to publish this API through my API management instance in the dev environment, right? So, I've decided to use the ARM template to do it. So I started, researching about ARM template, and I came across this, ARM, schema for API management, and I started reading, this file, which has more than 6,000 lines, and I feel like, oh, my mind is gonna, explode, right? There's definitely, a learning curve here, and this is where our automation tools come to rescue, right? So in the first demo here, I'm going to show you how to use the creator to generate templates for this API, okay? So let me switch to my VS Code. And as you can see, under the food truck API folder here, I have 3 files. So the first file here is my Swagger definition for my API, okay? And the second file here is an XML file, which basically contains the rate limit policy that I want to apply to this API, right? And finally, I have a YAML file, which essentially is a configuration file for my creator tool. Basically, it tells the tool how to generate those templates, right? And as you can see here, I'm saying, all right, so my dev instance is called Contoso APM dev, and please create a version set for this API. And it contains all the metadata for this version set. And for this API, this is the version ID, version set ID, revision number, and this is the link to my Swagger file, my Open API specification, the link to the policy file, suffix, protocols, products, and things like that. And also linked to true means that please generate a master template for this API so that it links to all the templates for this API, okay? So now we have all the input files ready for the creator. Let's run the creator and see what happens. So let me copy the command here. Let me make sure I'm in the right folder, okay? So basically, I will run the creator. So you can see I'm saying .NET run create, which essentially runs the creator. And this is my config file. And now the creator is creating all the templates for this API, and it has just finished. So now if I go to the templates folder here, and the food trucks API, you can see a bunch of templates have just been created. So I'm going to walk you through these templates in a minute, but before that, I need to do 2 more things. So first of all, as you can see, so this is the folder structure of the dev repository that I cloned from the publisher repository. As you can see, as I mentioned, there is a master template for the entire service, which essentially links to everything, right? So the first thing I want to do here is I want to add an additional step to deploy the food truck API as part of the deployment. As you can see, I just added a block here. Basically, it says, okay, during the deployment, please deploy the food truck API, okay? And this is the master template of the food truck API. Okay, save. And then supposedly now I have everything ready for this API. So I want to commit and push my changes to my developer repository, which was cloned from the publisher repository. So let me go to the Git tab here. Let me make sure, yeah, these are all the files I want to commit. Okay, say, okay, added a new API, commit, and push to my developer repository. Okay, so as soon as the changes are pushed to my developer repository, it will actually trigger a build and release pipeline in Azure DevOps to deploy my changes to the developer instance. So that's why I want to start it right now. Okay, so now supposedly the build and release pipeline is running, so I can walk you through the files that were generated by the creator. So as you can see, the first file here is the API version set template, which essentially creates the version set for this API with all the metadata that I provided, right? And then there is an initial API template, which creates this API with all the metadata such as API version, version set ID, display name, path, protocols, and so forth. And then there's a subsequent API template, which essentially imports the Swagger file, applies the policy to this API, and associate this API with a product called a starter. This is all from my YAML file for the creator tool, okay? And then there's a master template, which essentially links to all these templates that were created for this API, okay? And this is what I used in the service level template. So now let's head over to my Azure DevOps project and to check out the build and release pipeline. So my Azure DevOps project is right here. This is my project. And if I go to pipelines here, first of all, let's take a look at the build pipeline. As you can see, my build pipeline for the dev environment is still running. And if I click on the edit here, it will give us the definition of this pipeline. So there are essentially 3 steps here. In the first step, I'm using the Azure blob file copy, which essentially copies the files, the templates, from my private repository to a storage account because the Azure Resource Manager cannot access my templates in a private repository, right? So as you can see, the sources here is the templates folder, and this is my blob storage information, right? And in the second step here, I'm using the Azure deployment step, which essentially has a validation-only mode. So it does not really deploy those templates. It actually validates the syntax of my templates to make sure everything looks correct. And once it passes this step in the build pipeline, it will then publish the build artifacts to my repository, to my project. And as soon as the build pipeline finishes, it will then trigger a release pipeline. Let me show you right away here. If I go to releases, so now my build pipeline has finished. My release pipeline is happening right now. So if I click on edit here, it's very simple. Essentially, there's only one step. It's the Azure deployment task again. So this time, instead of using the validation-only mode, I'm actually using the incremental mode, which actually deploys the templates that I have checked in. And as you can see here, it's finding the template from the artifact, and it's deploying the master template for the service, which will link to everything else. And then here, I'm overriding the template parameter called API service name to make sure that I am deploying to my dev environment, not my prod or other environments. Okay. So now let's go back to releases and see if our release has finished. It's still happening. Okay, so it will take maybe 1 more minute. So for now, let's pretend that the release finished, right? My API has been deployed to my dev environment, and I have tested it, and everything works fine, right? So at this point, as an API developer, what I want to do next is to publish my API to the production environment, right? But obviously, as I mentioned, as an API developer, I do not have access to the production environment. So to do that, I will have to submit a pull request to the publisher repository, which includes all my templates. So let's go to the Azure repos here. And it already knows that I have committed something recently. So let me just create a pull request right from there. And these are all the files that I have committed for the food trucks API. Okay, I'll just create. Okay, so now the pull request has been created. So as soon as the pull request is created, it will actually, Azure DevOps will actually call a webhook that I implemented using Azure Functions to validate the compliance of my templates. So yeah, so we have just heard back from the validation process, which says, okay, only HTTPS is allowed in protocols. So apparently, I have made a mistake somewhere. So let me head back to my VS Code. Let me go to the API template. Oh, that's right. So under protocols, I'm saying HTTP, but my organization only allows HTTPS, right? So let me change it to HTTPS. And now, if I go back here and commit the change, fixed HTTP, and push it to my developer repository again. So as soon as the change is pushed, it should be picked up by the pull request, which it did, right? So now the pull request has been updated. It will trigger that validation process again to recheck all the things that I committed. Okay, so now, as you can see, it says approved for merging, right? So everything looks good. So at this point, as an API developer, my job has finished, right? So now let me switch my hat and say I am the API publisher who manages the production API management instance, okay? So as an API publisher, I just saw a new pull request came in, right, from this developer. And when I come here to the pull request, I see, okay, the validation process says, okay, it's approved for merging, everything looks good. Optionally, I can manually review all the templates again just to make sure, right, to double check. And after that, I can complete this pull request, which will merge the changes to the publisher repository. And then as soon as the pull request is merged, it will trigger a very similar build and release pipeline to the production instance, which I will show you right away. So let's go to the pipelines. So as you can see, for my production environment, I have a build pipeline which is running right now, and it is very similar to my dev build pipeline, which essentially copies the files to blob storage, validate the syntax again just to make sure. And then if we go to releases, if I go to product release, so first of all, let's check if my dev deployment is it's finished. So if I go to the product release, you can see that if I click edit here, you can see the definition of my production release pipeline. And it's a little bit different from the dev release pipeline. So if I go to the Azure deployment step here, so the difference here is that I'm overriding the template parameter here again to make sure I'm deploying to my production instance, not the dev instance, right? And I also have additional step here, which essentially adds a release annotation in my App Insight instance, which essentially will show the time points when each release happened, right, in the charts in App Insight. So it will make it easy for me to quickly spot any issues after each release, okay? So at this point, my release to the production is running. So we're not going to wait for that to finish. It will take a couple of minutes. So in this first demo, you have just seen that I used the creator tool to create ARM templates and used ARM templates to deploy my changes to the dev and the production environment through the pipeline that I built. Okay. So I also want to show you the extractor tool. So in the second demo, I want to show you how to use the extractor to extract your existing configurations from API management into ARM templates. So for the second demo, I'm going to publish another API to my dev instance, right? And I'm going to use our brand new VS Code extension to do that. And this extension is currently still in private preview, so you are the very first crowd to see it in person. And if you're interested in participating in the private preview, please let me know after this session. So let me switch to my VS Code again. And under the extension list here, as you can see, I have the API management extension installed, version 0010 alpha. And if I go to my Azure tab here, so in addition to my other Azure resources, now I can see API management here, right? And this is my Azure subscription, right? And under this subscription, there is a list of API management instances. Now you know why we have tens of thousands of customers, because it's just it's just all us playing around. Just kidding. So this is my APIM. My dev instance, my dev APIM instance. Let me refresh this list here. Under APIs, now you can see the food track API, which we just published to the dev environment, right? Okay, so you can also see the other API I have. So as I mentioned, I'm going to publish another API to the dev environment. So let me go here and copy the link to the Swagger file. Okay, this is the second API, which essentially is a demo conference API. It's a very simple API, it just returns some metadata about a conference, right? Okay, so let me go back here. So if I right-click on the API here, I can say import from OpenAPI file or import from OpenAPI link. So I'm going to say link and then paste the link, and then, okay, it's asking me to enter an API name. Let's say demo conf, okay? So now the Swagger file is being imported into this API management instance. It's exactly the same functionality that people use on the Azure portal, right? So while this Swagger is being imported, let me show you some other functionalities of this extension. So if I right-click on my subscription, obviously I can create new API management instance here, right from here, without leaving VS Code. And then if I right-click on APIM instance, I can open it in a portal in case there are some functionalities which are not supported yet in the extension. I can also copy the master subscription key of this APIM instance. I can also delete this APIM instance. Be very careful about it, because it's so easy to delete your production instance here. And then if I right-click on the APIs, I can import OpenAPI specification. And I also have a policy document, which allows me to apply global scope policies for this APIM instance. And then for the API level here, I can also apply policies at API level, as well as for the operation level. So if I click on the demo conf API that was just imported, it will give me the ARM payload of this API, so I can make some very quick changes here. For example, I can change the display name right from here or the path. Very, very easy. If I right-click on this API, I can also see the OpenAPI view of this API. It's exactly the same OpenAPI document you see in our designer in the Azure portal. Okay, let me close these files. Okay, and then if we look at our demo conf API, this is all the operations for this API, right? I can also delete operations and things like that. So the first thing I want to do here is I want to apply a policy to the conference API. Okay, so I'm going to add a policy here. Okay, And let's say I'm going to add a rate limit policy. So as you can see, we also have policy snippets enabled here, which makes it all easy for you to add policies. So for the counter key, I'm going to use a named value here called rate limit key. So before this demo, I've already created a named value in my APM instance, which contains a C# snippet. There's a reason why I want to use a named value here, which you will see in a minute. So let me save these changes. Now it's asking me, do I want to upload my policy change to my APM instance, right? So I'll say, okay, upload. Okay, so now it's updating the policy for this API in my APM instance, and it has just finished. Okay, so now everything looks good. Let me try to test this API, right? So to test the API, we can actually do it right here from the VS Code extension. So if let's say we're going to try the get sessions operation. So if I right-click on that, I can choose test operation, which actually uses the REST client underneath, so I can make API calls right from here without leaving VS Code. So okay, so if I make a call from here, obviously it will fail because I'm not attaching a valid API key, right? So what I can do is I can right-click on the instance and copy the master subscription key and replace the value here. Alternatively, you can also create an extension variable in VS Code, so you don't have to do this every time. Okay, so now if I click send request, okay, I got a response immediately. If I keep making calls, finally I got throttled because of that rate limit policy, right? So you can do a lot of things here, a lot of API management things here in this VS Code extension without leaving, VS Code, and to me, it's a very convenient surface for managing your APIs in API management. Okay, so now our new demo.conf API looks good in the dev instance. So the next thing we are going to do is to extract the configurations of this API from the API management instance into ARM templates, so we can submit another pull request to the publisher repository, right? Okay, so to do that, let me go back, close this windows, go back to my command file. Okay, so let me copy this line here, which runs the extractor. Okay, so essentially it says .NET run extract, which runs the extractor, and this is my source API management name from this resource group, and this is the location where to generate the files. This is the API that I want to generate, demo.conf, right? And now the extractor is running. It says, okay, it found the API. Now it's extracting all the operations under this API. And then it will also extract the policies, okay, and also related entities of this API. Okay, so now it has finished running. So if I go to the Explorer again, under the templates, under conf API, now you can see a bunch of files have just been created. So the first file here is the API template, which contains the definition of the API, right? Such as so this is the API definition, and all the I think this is the schema of this API, and then all the operations under this API. And the very bottom here, it's the policies of this API. As you can see, it links to a file called demo.conf-API policy.xml. It's actually under this policies folder. And as you can see, there's an XML file which was also extracted by the tool, and this is exactly the policy that we applied to the API, right? And then if I go to, as you can see here, it's still using the rate limit key, named value. So if I go to the named value template here, you can see the rate limit named value is also extracted by the tool, and here is its value, which is a C# snippet, right? So that's because the extractor is smart enough to know that it also needs to extract all the dependent entities of an API. So with this tool, you can easily extract all the configurations of an API into ARM templates so that you can deploy that into a different environment. Okay, so that pretty much wraps up my demo. So you have seen the sample CI/CD pipeline implemented using Azure DevOps. You have also seen our automation tools, the extractor and the creator, and you also got a preview of our VS Code extension. So here are some final takeaways. So essentially, we recommend using separate service instances for different environments, and you can use the developer or the new consumption tier for your pre-production environments, right? And we recommend using the templates-based approach for a variety of reasons. For example, it's consistent with the rest of Azure, it's declarative, It supports RBAC and partial deployments. And also, if you modularize your template properly, it provides a wide degree of flexibility, right? For example, you have different API teams will be working on different APIs. You can deploy your configurations partially without needing to deploy everything else, right? And however, if you have been using other deployment options and it works great for you, there's no reason to move to this new approach. You can keep using whatever you have implemented already. And finally, as I mentioned, the automation tools that I demoed are open sourced on GitHub. And the VS Code extension will also be open sourced on GitHub. So community contributions are greatly appreciated. And finally, here is a link that Mike created, where you will find everything you need about API management. Thank you.
Covey.co